Hello, I'm Nathaniel and today we'll now be doing A-level mathematics. Today we'll go through the topic of series and the binomial theorem. Why am I doing 2 chapters in a row? You see later. Anyways, the textbook I'm using is by Linsky, Nicholson and Weston and is made by the Oxford University Press. The plan on the schedule is that I'm going to do chapter 7, then chapter 6. Because what? Because the binomial theorem, as it's called, is actually just a series of coefficients. Get it? And it's one of the most complicated series to master. And you haven't mastered the AP or GP as I call it, then you can't measure the binomial theorem. Get it? On to arithmetic series. An arithmetic series is of the form A plus D, A plus 2D, A plus ND. The first term is A and the common difference is D. The end term of the series is A plus N minus 1D. As you can see, the first term is A, so the end term is A plus N minus 1D, unless you count like a programmer, in which case it's A plus ND. So the sum of arithmetic series, sum of the first n terms of the series. Well, this calls for the deriving formula snippet. Okay, so we just sum this, and then we put all the n a's together, and then we put all the d's together, then we use the linear formula, and then we take away n over 2 from the expression. Example, what is 4 plus 7 plus dot 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 plus 256? Well, you can't compute this in your head. The number of terms is 85 because when you subtract the first and the second and the common difference is 3 at 1, you get 85. It's still transpose error. 8 equals to 4, D equals to 7 minus 4 equals to 3, N equals to 85. So the sum, using a bit of algebraic twiddling, you get here 11,050. This result, I had to check it 3 times to get it right, because if not, then people would probably laugh at me for getting the answer wrong. On to geometric series. A geometric series is of this form: AR squared, ARN. The first term is A, the common ratio is R, and the nth term of the series is ARN minus 1. The sum of geometric series. This calls for another deriving formulas. Then, first we sum, then we factor out A, then we do some algebraic twiddling again, but this time multiplying both sides by 1 minus R over 1 minus R. Why? Because when you expand it, then you get lots of terms which can be easily cancelled, and you get this nice little thing here. Example, what is 2 plus 6 plus 80 plus dot 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 plus 106,282? Now, you obviously can't compute this in your head. I can't, but some human calculator who can figure this out. Well, that's great. Number of terms equals to log 3, 106,282 over 2 plus 1 equals to 13. A is 2, R is 3, N is 13. So the sum, using the formula, is 1594322. Again, I checked this value. Infinite geometric series. So let's suppose you had a square cake. I know that's weird, but I love square cakes. So say you have an infinite number of friends. So one of your friends cuts off half of the cake for himself. Then another one of your friends cuts off a quarter of the cake for himself. Then 1/8, then a 16th, and so on. 1/32, 1/64, 1/128, 1/286, and I do not know how far this series goes. But anyway, you will still have the whole square cake, because for the geometric series to converge, the modulus of the ratio must be less than 1. The sum of the series is A over 1 minus R, and you substitute 1 is A, and R is half. No, A is half and R is half into the equation. You will get 1. Example, what is 1 plus 1/3 plus 1 over 9 plus 1 over 27 plus dot dot dot? A is 1, R is a third. So sum equals to 3 halves. Then, understand? But sometimes the infinite series formula goes wrong. How? Well, take the series 1 plus 2 plus 4 plus dot 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 dot. So, using the infinite series formula, you get -1. How could this happen? Yeah, I was thinking about this solution for a while until I realized it had a particularly elegant solution if you're talking computer science. Because you see, in 2's complement, basically, let's say you have an 8-bit display, so you have 255 in 8-bit display is -1 in 2's complement. Similarly, you had an infinite bit display. And also, it also is convergent through the 2-adic metric, which basically is just an extended binary system with the recursion going to the left instead of the right. There, I hope my description of two-addic numbers fits well, and I even tried experimenting with two-addic numbers once. Probably didn't go well. Binomial series. Well, you might know this one from um, secondary school. Expanding the brackets will give you these. So what on earth are the coefficients? Suppose I have 5 objects. The ways I can choose 2 of them are these. This is written as 5 over 2, which is 10. A closed form expression of nm equals to this. Now, where does this come in handy? Back to the binomial theorem. The binomial theorem states this. So with this, we can conclude these 3 facts about this weird vector-like weird function. Example, calculate this. Using the binomial theorem, I expanded it out for you, but since I normally don't expand this out for you, but since you want to learn more about the binomial theorem, I just expanded it. So we substitute and simplify, and there we go, our final expression. And don't forget to share this video with your friends and subscribe. See you!